Now we have talked much about binary trees, and let us now do some coding. I mean, let us write some code and get our hands dirty with C++ code. So I've created a new file called node.cpp, and I'm going to hash include iostream, and then hash include. Let us not include anything now, using namespace std, so that I don't need any kind of std cout or something. Let us now create a structure. It's struct node, and then in data. So this is a structure, and in this structure I'm going to store three values. First is data, then another structure. It's going to be pointed to the same type of structure, and I'm going to name it left, semicolon, and then struct node star right. What is this? This is a structure, the node structure. This is the value inside that node, and then this is the left pointer, this is the right pointer. Now this much should be clear, and now let me create the main function. Int main, and I don't want to use any command line argument stuff. I just want to, this is okay for me. Now I'll do one thing. I'll create a function. Let's not write any function. I just want to okay, let us do it. Let us just write a function to create a new node. Struct node star new node, and it will take a integer value, and it will return some node that I'm going to define. Now let us do one thing. Let me create a pointer to this type of this type of structure. Struct node star node is equal to new struct node. I just did dynamic memory allocation, and we do it using new keyword in C++. So what is this? I created a new node, and it is allocated memory dynamically. So this is a pointer to a structure, this type of structure. Okay, so let us do one thing. Node data is equal to the data. Now this data is this data, and this data is, let me make it I data, which is input data, so that you don't get confused. Now node left will be null, and node right will also be null. So let me copy paste because I'm lazy bum. Right. Now I'll return node. That's it. That should work. Time will tell everything. I don't know if it's going to work or not, but let us see if it works. So now I will write my main function. In my main function, I'll say struct node star root. I'll create the root node is equal to new node. New node is the function, and let us keep 9 inside this node. Now I'll say root left is equal to new node, and let me say 87 or 8 is fine. Root. Okay, by the way, if you don't know what this is, this pretty much means star root dot left. This time I'm going to do right, so new node, say 3. If you don't know what this is, I'll include links to the useful videos in the description, so that you know what it is. So let us run this program now. I'm using Sublime Text, by the way, and I've linked G++ compiler with Sublime Text. If you want to know how to do that, please let me know in the comments. Let me run it. There is some error, and it is expected a semicolon, which is a very common mistake. So yeah, but I've not done anything. It wants me to do something. Let us see out root left and left. But before that, let me assign it a value. Root left is equal to new node 8 or 823. So output of this program should be 823. But there is some problem. What is the problem? The problem is I should print the data, not the pointer. This is a common mistake. So the value of the output of this program should be 8 because root left is 8, and if I do a left and data, it should be 823. Now let's run it. But before that, let me close this command line. Tools, build, 823. So I hope you got what a binary tree data structure is. We'll talk about binary search trees, as well as I'll also create some videos on how to use Sublime Text for competitive coding, how to use Sublime Text for how to use Sublime Text with G++, Python, C, and everything I'm going to do on this channel. So make sure to subscribe, and I'll see you guys in the next video.